Howdy, this is the Amateur Logician. As part of our series on the textbook First Course in Mathematical Logic by Patrick Suppes and Shirley Hill, we will be looking at section 1.4, Symbolizing Sentences. For those of you who have watched the previous videos, you already know we have covered the idea that sentences can be symbolized with letters. So we jumped a little bit ahead of the textbook, but that's okay. We will carry on and soon things will get more interesting. So symbols can stand for sentences. However, remember one thing, that these sentences must be declarative. Otherwise, we can't symbolize them. That is, a sentence has to be in principle either true or false exclusively. If I say Socrates is in this room, I can symbolize this because it declares something to be the case. It is either true or false. I'll let you guess if it's true or false. So Socrates is in this room. We can symbolize it with a capital letter, such as S. So S represents the particular material content. Socrates is in this room. We might think of S as a fixed variable. We have stipulated that S stands for Socrates is in this room. A question, a mere wish, a desire cannot be symbolized because it's not true or false. If I ask the question, is Socrates in this room? It's not declaring anything to be the case, hence we cannot symbolize it. Anyways, why do this? Well, one reason is that analyzing complex molecular sentences will be easier. If we have a very long complex sentence, it's very tedious, it's difficult to write, it's difficult to analyze, but if we can boil it down to its essence, to its formal structure, then things become more straightforward, more easy. Also note that a molecular sentence will always have at least one sentential connective. Once again, I'm jumping ahead of the textbook, but that's okay. I'm not going to let that stop me. If we think about the and, the or, the not, the if, then, we also symbolize these. For example, the and, we will use the wedge. The or, we will use the descending wedge. The not, we'll use either the tilde or this symbol. I don't know if it has a name. If it does, please let me know. And then the if then, we will use an arrow. So by symbolizing atomic sentences with a capital letter, we can relate those atomic sentences with other atomic sentences via these various sentential connectives, such as the conjunction, the disjunction, the not, the if then. Another sentence might be Plato. There we go. Plato is in this room. We'll give that a P. So P will stipulate means Plato is in this room. And we could form a molecular sentence such as S and P. Socrates is in this room and Plato is in this room. Or alternatively, we might form the sentence, the molecular sentence, it is not the case, S, not S. In other words, it is not the case that Socrates is in this room. Okay, let's look at exercise 3, part A. At least we'll look at some of it. This is on page 11 of the Suppes and Hill textbook. The instructions tell us to symbolize the following molecular sentences by replacing the atomic sentences with capital letters. Actually, we'll do more than that. We'll translate the entire molecular sentence, which is composed of at least one atomic sentence. We'll symbolize that with a capital letter, and then we will also symbolize its sentential connectives. Sentence 1 tells us, I need to put on my glasses, or this light is poor. By the way, is this declaring something to be the case? The answer is it is. In principle, it could be true or false, so we're good to go. And it is a molecular sentence. We have the or sentential connective, so it's a disjunction, and it's composed of two individual atomic sentences, namely, I need to put on my glasses, which we will give a G, capital G, and then we have the other individual atomic sentence, the light is poor, which we will give an L. It is a disjunction, so we need a descending wedge, G or L. Sentence 2, ducklings do not grow into swans. We have the not sentential connective, and in this case there's only one individual atomic sentence. Ducklings do grow into swans. We'll give that a D, but there is a denial, so we just say not D. Sentence 3, he walked 3 steps to the right, and then he went 2 steps forward. It's a conjunction. We have the and. There are 2 individual atomic sentences that compose this molecular sentence. The first one is he walked 3 steps to the right. We'll give that an R. And then we have, then he went 2 steps forward. And we'll give that an F. It is a conjunction, so we need a wedge. R and F. Sentence 4, these problems are not easy for me. It's just like sentence 2, it has the same form in a formal abstract sense, right? Although obviously they represent 2 different statements. They have 2 different individual material content. We have the not. Then we have these problems are easy for me. So we'll just say E for that atomic sentence and then not E. Not D and not E represent totally different statements. But notice, even though they represent totally different things, they have the same form. Sentence 5, if the buzzer sounds, then it is time for class to begin. We have a conditional, if then. And it turns out the antecedent is an atomic sentence. The buzzer sounds. We'll give that a B. And then the consequent is it is time for class to begin, and that's another atomic sentence. We'll give that a C. It's a conditional, so we need an arrow. If B, then C. Jumping ahead, let's look at part D of exercise 3 on page 12. It's the same idea. We're going to symbolize each atomic sentence with a capital letter, and then symbolize the sentential connectives. So, sentence 2, we have if x is not equal to, then y is greater than 1. We'll say that A represents x is equal to 2. We'll say that B represents y is greater than 1. Notice that the dominant sentential connective is if then. So we'll say, what is in the antecedent? The antecedent happens to be not A, so not A, arrow, B. So here we have 2 sentential connectives. If not A, then B. In other words, if x is not equal to, then y is greater than 1. For sentence 10, we also have a conditional. We have if x is not equal y, then x is not equal 1, and x is not equal 2. We have 5 sentential connectives. We have a not here, a not here, a not here. We have the if then, and we have a conjunction. What's dominant, nevertheless, is the if then. Because the textbook wants us to use capital letters for each atomic sentence, we'll just say that A represents x equals y. We'll say B is x is equal to 1, and C is equal to x is equal to 2. So then we have this antecedent, which is not A. The consequent contains a conjunction, an and. So let's begin with the antecedent. If not A, then. So what is in that consequent? Not B. So x is not equal 1. and we have the conjunction, x is not equal to. So in other words, not C. So sentence 10 is, if not A, then not B and not C. Not too bad. We're marching along here as we learn propositional logic. Up next is section 1.5, sentential connectives and their symbols. Thank you for watching.